Did you see that notification about the security?
Was that
The
the
table?
postman?
No, it was.
Let me just
It
check.
was Subbase.
Oh, from Superbase. Yeah, I think I know what that one is about. I'll look into that.
It's a table publicly accessible.
Accessible, yeah. So we'll sort that out. Okay, so I think to kick us off, I know the promise was to look at cloud patterns. I didn't want to call them patterns. I rather called it like an approach for using cloud. And so we're going to look at it on two sides. So one side is we're looking at scaling. So meaning how do you handle more requests by increasing your throughput? So how many requests per second you're able to handle, as well as your latency. So you want to cut back on how slow or the response time it takes to handle a request. And then we're also going to look at on the side of reliability. So if one side of your system fails, how resilient is your system? Like how can it handle maybe one of your nodes coming down? Does that how does that impact your system, or how do you make sure your system isn't impacted? You know, the user experience still remains pretty much the same if one of your nodes dies or has an issue. So there are six things we're going to look at over here. So the first one is auto scaling and elasticity. So there are some cloud services out there that allow you to add or remove capacity depending on how many requests that you have. So there's AWS auto scaling groups. Google Cloud has managed instance groups, and then Azure has VM scaling. I can't remember what that acronym stands for. But these cloud providers do have services that out of the box allow you to add or remove nodes in your virtual machine. So if you have one virtual machine running, it can spin up like a copy of that virtual machine, depending on the traffic that your system is handling, and based on your resource utilization. So you could say if maybe CPU is being utilized at 90%, then spin up another VM so that that spreads your traffic across the like instead of just having it come to one machine, you can spread that across more than one machine. The other one is adding in load balancing. So load balancing is primarily just spreading your traffic and routing requests to the nearest healthy region. And like we mentioned before, you could have an application load balancer, a network load balancer, you could have a cloud load balancer, and those are services that you're using to handle your load balancing in your system. And we did explain what the difference was: the application load balancer and the network load balancer. So they're sitting at different layers of your OSI model. The other thing we want to ensure is the statelessness. So we say the reason for this is that it allows for any instance in your system to handle a request. Because if a system, so let's say you have two computers, you have A and B. If you make them stateful, so meaning let's say a user sends their first request and the state was stored on computer A, it means that all their subsequent requests that depend on the initial state would have to be routed to application A. So you'd have to hard code that in your load balance or in your routing logic. But when you make it stateless, it means that any machine can handle a request. So the first user's request might go to A, and then maybe in their subsequent requests, A is at capacity, so you could route that to instance B. So some of the services you can use JSON web tokens. You can use Redis for statelessness, and then your state lives in a cache. So the state would live in your JSON web token. It would live in your like a Redis instance or main cached, rather than living in your actual request or living on an actual like server or computer, which is the final destination of the user's request. And then finally, you have multi-layer caching and CDN. So what this does is you're basically just storing your static content at the edge. Like we mentioned, and you could use something like a service like CloudFront or Cloud CDN or Cloudflare. and then these will serve your static assets or content closer to the user. So static content, this is information that's not changing. So in the case of, like, you have a streaming website, you have videos that users are constantly having access to. So those can be served closer to the edge. So you can store those in a CDN, content delivery network. And for example, you have an e-commerce website and you have images of your products. Most of the time, the images are not changing that much. Maybe what's changing is just the price. So things like the description and the actual images themselves of the products, you could keep them in a CDN rather than having a user request to hit your database or your actual like node or server for them to receive this content. The next one is queue-based load leveling. So what we want to introduce is asynchronous queues, and these just act as a temporary storage or a temporary hold for user requests that cannot be handled there and then. So it still gives a smooth request. It still gives a smooth experience in your system, such that your system is only able to handle what it can handle at a particular time. So it prevents your system from being overwhelmed. So the queue will temporarily store that information for you. And so some of the services you can use Amazon's simple queue service, and you can use Kafka, which is like a PubSub type of system. So with Amazon, you would use something like Simple Queue Service for the queue, and then you would use something like SNS to notify a worker to pick up whatever is in the queue when it's full or whenever there's any request that's stored in the queue. And then finally, we mentioned you want to partition your data. So this make sure that you're splitting your load across multiple nodes rather than all requests going to one node. When you split your data, you can spread your requests across these different nodes that you would have. So some of the tools you could use Aurora, Cloud Spanner, and Cosmo DB, which comes with partitioning out of the box.
So let me ask: have you used any of these services in the past?
Yeah. So one of the ones I use currently is I do have a website that I launched with Cloudflare.
Yeah. So I use
So
Cloudflare for security,
for security, yeah, it's very,
but
very good for security. Yeah.
but you use it for caching.
For caching, yeah. So all my static assets, I store them when I'm coding my projects. There's a public folder where I put that information. So automatically it will pick up that data inside your public folder and then cache that for the user. Another
So
one,
like, so you're talking about like any JS, CSS.
that's when I'm using React. Yeah, so right now I just use it for images and any documents.
Like what what type of documents?
So like in my case right now, I have a personal portfolio. So for things like my resume, I'm putting that in my public folder. And then for things like my image or like a
So
headshot,
Cloudflare automatically does that because I wonder if I could use that for. I mean, I know I could,
yeah,
but I mean, I could use it for. So like we have our images folder, we have our JS folder, we have our CSS folder, like big picture,
yeah,
where they're just they don't those files don't change much.
hmm,
So you're saying I could use Cloudflare to cache those,
to cache those, yeah,
and then whenever
so that can be a huge optimization on the website by caching.
so yeah, I would be as we go through this, I would be interested in like every time we do a bite by bite, maybe at the end think about like, well, what's one thing that we could implement to make VSC better,
Better, yeah,
like
absolutely,
so like it sounds like maybe the easiest thing out of all of these could be Cloudflare,
yeah,
but maybe there's something else. Our database isn't super huge right now,
hmm,
but I am starting to do more logging. So like
yeah,
right now, I'm logging all the people who use the mobile app. I don't
Okay.
log everybody who logs into the web. I just track the number of logins
Yeah.
and I track their usage, but I don't necessarily log a instance of a login. But with the mobile app, I'm actually logging an instance of a login
Yeah.
so that I can later find trends and look at um, adoption and maybe even try API calls later. But I mean, there might be a way to use some of this if we do scale. Like right now, our scale,
Yeah.
2 to 4,000 students a year is not enough to want to over engineer
That's right.
scalability things. But I mean, if we grow now, that's the bigger question because like right now, like I don't see in the next 12 months us like onboarding like the Chicago public schools or something, right?
That's
Like
right.
if you onboard, 50,000 students, I would probably want to look at this before we launched with that.
Hmm.
So, um, but yeah, I'm just thinking, I'm just kind of talking out loud, thinking through because we're definitely not optimized right now for a spike.
Yeah.
But there's really no risk of a spike because we have a real fenced in user base.
Yeah.
You know,
Yeah, I think the other one I've used before is SQS and SNN. So these are from Amazon. So SQS, a simple queue service, SNN, a simple notification service. So it was at Amazon, one of the projects they gave me to work on. And so what was going on is you had a system that used to automatically publish tickets. So what we wanted to do is to do some processing to these tickets. So what we would do is we would put the destination of that ticket in a simple queue service, and then you had a simple notification service that would listen to the simple queue service. So when the queue receives a ticket, the notification
so you're talking
service.
about like a bug, like somebody's posting like I need help,
I need help. Yeah.
like a
So
help
these would be
request.
tickets, both automatically published as well as manually created tickets that are assigned to our organization. So there was some criteria we would use to pick a qualifying ticket. So what the simple notification service would do is it would listen to the queue, and then it would notify some other service. So in our case, we had a Java function that was running as a lambda function, and then so the notification service would then trigger the Java Lambda, and then the Lambda would do some processing and then write back to the ticket. So we were using both the queue and the notification service in that instance.
Mm.
Yeah. I think, yeah, we could go to this last one. So I guess what are some things that make your system resilient? So how can your performance still stay fast even when you have failures within your system? So some of the approaches we could think of is having redundancy. So what you could do is when you're using cloud services, sometimes a zone or a region could be impacted. Sometimes there's a service in a zone, maybe that's down. And so what you could do is deploy your service across multiple regions or zones. So that way, if one zone is affected or one region is affected, you could route your traffic to the more healthy region. And then another thing you can do is introduce health checks. So there's a small project I was working on for somebody, and we have an endpoint to our backend right now where when you ping that endpoint, it does a health check of the database. So it makes sure that the database is running, and then it does just a small smoke test to the database to make sure that you can write data and then you can read back. So anytime we're checking if the system is healthy, we just ping that endpoint, and then if it returns a 2xx response, then you know it's healthy. If it's 4xx or 5xx, then you know it's
So
unhealthy.
that's kind of what we're doing with the Postman APIs, right?
Yeah, pretty much. So
It's
we
more or less a health check.
a health check, yeah, just to make sure all the endpoints are
Um,
working correctly.
yeah,
And then what you could do is you
I
could,
do health checks a lot.
Yeah.
That's probably my main resilience.
Right. Yeah.
It's pretty. It's probably the easiest thing to do.
Yeah. That's right. And then another one is having a circuit breaker or a back off. So this one I think we had explained before. So it's a system where you could have some kind of checker within when you're handling your requests between two services. If one service that's app top is receives a request and then that request causes a failure, what the circuit breaker does is that it can stop routing traffic to that system up until it heals. So that's important because you would stop calling failing dependencies. So it can notify your system that, hey, one of our services is down. So we stop routing traffic to that service rather than you keep allowing traffic and then it receives a failure response. So it's a better way of handling that. Another thing is you want to isolate and degrade your systems. So by isolating, you kind of have your services not fully depending on each other, so that if one of them goes down, the blast radius or the number of impacted services are not that many. So in this case, I guess you would introduce things like microservice patterns, so where different services are kind of broken down into these smaller.
Give me an example of that.
So thinking of a microservice, I guess I could give you an example of, like, let's say you had a monolith system. So
A what?
monolith system. So in a monolith system, all the different components of your system sort of live underneath one code base or within one system. So for example, you have your front end and then your back end.
Use the VSC as an example, like the mobile
So
app,
or using the mobile app
as an example.
as an
Explain.
example of this. So I can imagine a situation where the code base that we have right now, React Native, and then your backend service as well, which we're running in PHP. Imagine that we deploy both of these into just like one VM instance. So I guess a mobile app doesn't really give the best example because your front end is leaving somewhere else, and then your back end is in a different system. But let me think of it as what's one example that I think would make a lot of sense here. So let's say you have two different systems. So one is like your ticket service system, and then maybe another one is handling your checkout, and then another one is actually sending out tickets after like a complete purchase has been made on the purchase system. So when you deploy both of these on one system, it means that if there's an error with the checkout, then the ticket system as well will be affected because they both live on the same computer. So let's say that checkout system has a bug, or maybe there was some dependency we released, or there's some security issue going on. So when that computer goes down, it means we can't publish tickets anymore.
So, is it similar to like with the VSC? We have our LMS on one
On
machine,
one
and then we
machine.
have VSC on another machine.
That's right.
So, if something happens to our Moodle instance,
Yeah.
where Moodle gets hacked,
Yeah.
it won't
It won't
impact the
impact
VSC.
VSC. Yeah. So you're reducing the blast radius, the number of services that are going to be impacted by.
So basically, I mean, that's kind of like the world you live in, where you integrate uh, with a lot of like APIs. So even like if the mobile app goes down, it doesn't mean the web will go
The
down.
web
Like
goes
they're
down.
living in different places.
Yeah. Yeah. And then another thing you want to do is rate limiting of your system. So this is mostly used if you are providing, let's say, an API service to developers. And so you want to apply rate limiting. So you can only handle certain number of requests per second. And so if you give me like an API key to handle, I mean, to access this service that we provide, then what we can do is we can cap how many requests that you can send per second. It's the same thing that sometimes AI will do. Like I know Gemini, sometimes if you send a request too fast, it will tell you that there's an error because they apply rate limiting.
So
So
I'm doing that on. So I have like a lead generation form for scholarship providers
Hmm.
where they can request a demo.
Okay.
And maybe like within a month when I first launched it, someone
Oh,
sent like 20,000 requests within like an hour.
right.
And I got like, it took me like all day to delete these emails. Like I couldn't even do
Wow.
the select all because it was too many. It would only do
So
like
it
a
would
batch.
paginate them
Yeah, so
in
I had
the.
so many. So I added rate limiting where I'm looking at an IP range
Mhm.
and whatever, dropping a cookie, whatever, where at that instance can't submit another scholarship provider request.
Yeah.
So one, I added Cloudflare. Two, I added a rate limit
Yeah.
so that they can't just keep hitting submit. Like they can't do it. So rate limiting is not only for making sure your system is resilient. It's also a security protection
Hmm. Yeah.
because I think that's just, I guess, probably a denial of service attack. They're just
Hmm.
trying to send so many requests that nobody else can do anything
You can
else.
do it.
Like
Yeah.
they've gobbled up all your
Your
resources of your
resources. Yeah.
system.
Mhm.
I almost think rate limiting should be built into any public type system,
Yeah.
which I don't know if it is. I know I hadn't always thought about it, but any system where people are not required to log in, even usually you rate limit logins, right? Like
Yeah.
if you try to log in too many times with the wrong
Password.
password,
Yeah.
they lock you out.
Yeah. That's right. Yeah, and then finally, I mean, you want to have some observability in your system. So this allows you to catch issues way before your users actually see them. So you want to capture metrics, SLOs, and then traces as well. So traces are basically just tracking the request that was sent and all the services that that request went through up until it hit that particular error. So that's good for debugging and seeing what's that point of failure in the system, so
Hmm.
you can catch it early.
Yeah, yeah. We probably
I
should
guess
pause
yeah, we
there.
can end here and